So we have the problem number 100, same tree. It's an easy problem, and it says the following: given the roots of two binary trees P and Q, write a function to check if they are the same or not. Two binary trees are considered the same if they are structurally identical and the nodes have the same value. For example, one, we're given the tree 1, 2, and 3, and the tree 1, 2, and 3. Since they both have the same structure and values, they're both equal. They're equal. In example 2, we're given two trees. The first one has 1 and a left child of 2, and the other tree has a root of 1 and a right child of 2. Due to the fact that they're not structurally identical, they are not the same. So I don't know if you can scroll down to number 3 over here. Yes, thank you. Here we have a tree, an example tree, example 3. We got one tree with a root 1, left child of 2, right child of 1. And then we got another tree with root 1, left child of 1, and right child of 2. Right? They're structurally identical, right? But the values differ, which cause the tree to be not the same, right? So therefore, the output is false. This is yes.
All right. So I'm thinking,
Mm-hmm.
wouldn't this one be better for depth first search?
Ooh, depth first search.
Because like you could do
Mm.
the whatever order, traversal order you would like to do, and just compare if they're
Mm-hmm.
both the same or not. But I guess it would work
Mm-hmm.
the same way, right? If
Mm-hmm.
you do breadth first search. But I was just thinking of that.
I was I was thinking a breadth first search, right? Because I think you can do them both, right? But since since this is the focus of like the breadth, right? Breadth, I think we should approach that breadth, but it's mentioned in both topics,
Okay.
right? Both methods. Um, but here, this one, I was thinking we can create an algorithm, right? Or do the breadth first search and put all the values into an array, and then check if like all the children, all the roots into an array, right? Of both trees, and then we can check if both arrays are the same.
Okay.
If that makes sense, I don't know. Maybe.
Yeah. How about this?
Uh huh. Uh
To
huh.
make it that would definitely work. But to make it more difficult, would you want
No
to
array.
do it? Would you want to do no array and just
Mm.
have it where it starts at one tree? It starts at that root, and at the other tree it starts at that root, and you're both traversing at the same time doing the BFS
Mhm,
search.
mhm, mhm.
And then once it finds a false, then you just return false.
Oh, that'd be hard though. Hmm.
Really, you think
That'd
so?
be hard. I, well, to me, to my knowledge, I think so. I think so. I think so. Yeah.
Because you could um because I there was a problem called merge binary
Uh huh.
trees,
Uh huh.
and um, it did the same concept where you start at both trees and
Mhm.
then you traverse the same way,
Mhm.
and you call the way you called the function was like for example BFS, and then it would be the P is the first tree. It'll be P left, and then the other one was Q left, which is the second tree. And let me see. It'll be root dot left equals B something like that, where it
Okay.
works the same way as the binary search as breadth first search,
Yep.
but
Yep.
this time you're I'm trying to remember. You're traversing both trees at the
Mhm.
same time. So if
Mhm.
you're going left on the other tree, you're going left on the second tree.
Mhm. Mhm. Mhm.
But I was just saying if you want to make it harder, but that would work. What you said is to compare the
No,
arrays.
we could do it like that. We can do it like that. Um. Yeah, I think so. I think we can do it like that. I'm down. I'm down. I'm down. Yeah, for sure, for sure.
Okay.
I think I
Ali
got.
with the hello.
Hey,
What's up?
aside too. Welcome
What's
to
up?
the
What's up?
stream, Ali. Welcome to the stream. Hey, she's an OG. She's been here every
OG.
stream. Yes, sir.
Hey, we might need to
Hey,
get some moderators pretty soon. You
yeah,
never
we
know.
might get some moderators. Yeah,
Uh-huh.
yeah, yeah. Hey, so join the Discord. You might become moderator of chat and Discord. You never know. You never know.
Maybe, maybe.
Maybe, maybe. Alrighty.
What do you think? I
Okay.
don't know, cause I remember that's how like um,
Yeah.
what's it
I
called?
think. Mm,
Like the solutions. If you look at
yeah,
the
yeah, yeah, yeah.
solutions, it showed that way to merge it.
Mm, I think it's possible, but I've never done it before. I'm curious to explore that idea. So I'm down to do it and see where it go. But I do have to like get a visual first to see how everything's gonna work.
I like the array approach. How about let's try that one first?
Hmm. Bro. All right. Oh, but you left me now with the itch, bro.
Uh,
Like the what if, bro. The what if.
because I'm thinking like binary, breadth first search.
Uh huh.
I'm thinking of it as depth first search on doing that
Hmm.
way that I was just saying. But
Okay. Oh, okay. Okay. I see. I see.
so
I
I
see. I
wanted
see.
to
I mean.
stick with
Uh huh.
because the way when I was just telling you that idea that I saw in the previous
Mhm.
problem
Mhm.
that I did, which I didn't solve like by myself. I had to like search it. I was dealing with it for like a while, and I didn't know how to
Mhm.
merge them. I was like, okay, well, you
Yeah.
can't
Yeah.
just do your normal breadth first search on it. Yeah, you cleared. There was clearly something else that I was missing.
Yeah. Yeah. Yeah.
Anyway,
Yeah.
so that was what they did. Is they did it at the same time,
Uh
and they did it
huh.
all in
Okay.
one function. And I was like, that's really nice. And that was one of the way. That's how they traversed through it. And they said like the root dot left equals the call, which is the self. Um, I can't type. Self dot is same tree, and then they just called. Um,
P and Q.
it was like if
Oh,
p then yeah. Oh, another thing that they did was they did a if statement inside
inside
of
a
your function
damn like
call.
a parameter.
Yeah.
Damn,
So if
that's
I don't, I think it was written like this. If p, then you're gonna you're gonna say p dot left, something like that. Else, and then you're gonna say like you put in none because one of the base cases was if p if p and q. Oh,
uh-huh.
if not p and not q, then return none. And so then it would know, okay, there's nothing there anymore. In
Gee,
this
gee.
case, we could put, we could do that. And also, if this doesn't pass, then we could say if P and not Q, meaning like there's nothing on Q, but there's something on P, then that means they're different.
I was thinking the same thing. Like we can traverse, but we had to we have to put like different base cases.
Yeah.
You get me? But we can do that. We can, and if you want, we can do a breath verse because I feel like a breath verse would be more easier, right?
Breadth first or depth first?
Breath.
Okay. So
Yeah.
that's the Q's and stuff.
Yeah. Yep.
Okay.
Yep. 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 Wait. Let me see. Yes, I
The
think so.
one where
Yeah.
you
Yeah.
have a
Yeah. Yeah.
visited and a queue,
Yeah.
and
Yeah. Yeah.
then
Yeah.
yeah. Okay.
Okay. Alrighty. So you want to dry it out, or so
Draw it out. What
get
do you
like
mean?
an Excalibur or something to get like
Okay.
a good foundation
Yeah.
of this thing? You want me to get the link? I got you, my guy.
Oh yeah. Send me the link. Send me the link.
Yes, sir.
Ah.
Ah. Oh my god.
All right,
Oh my
fix it.
god. Let me see. I'm gonna send it through DM again. Yes, sir. All right, I got you. Should be good to go.
Okay.
Yeah,
Was
you got
this
it.
from a previous one?
Oh yes, yes, maybe.
I could delete.
Yeah. Delete everything. Delete everything. Yeah, this was from a
How do you?
past. Let me see. I got you. Wait, I think so.
All
There
right.
we go. Alrighty.
Okay.
Okay.
Orcus, what's up, bud?
Hey, Orcas in the stream. Welcome back. Welcome back, my guy. How you been? How's everything?
Okay. So,
Alrighty.
what? How did the tree look like?
I think it's one, two. Oh,
Sorry, Jose.
there you go. Yeah, no worries. You do you. You do you.
Okay. So then, now what? What do you need?
Okay. No, I'm good. I'm good. I have everything. I have everything.
Okay.
So you said you want to do a breath first, right? Or you
Yeah.
want to do a breath first approach? Alrighty.
Yes.
So we start first. P. Okay.
I wish I had a pencil.
We okay. So, how would you approach this though? Yeah, we've been good, Orcas. We've been good, thankfully. Thank God we've been good.
Q.
Um,
All right.
mm, mm.
So this is how what I remember from the solution. So we start. Let me see. We
Uh-huh.
start at the roots of both.
Yep.
This one's P.
Uh-huh.
This one's Q. Right.
Mm-hmm.
Then you see. Then you add. Huh. Okay. If we're doing breadth first search, you gotta add those to a queue.
We can
Hmm.
have both. We can have Q1, Q2, right? And we'd be like, all right, one. So here would put one in here, right? And one in here. This is gonna be one. This is gonna be two, right?
Oh, okay.
And
So
then
so two different queues.
yeah, and
Okay.
then we're gonna put visited. I think we'll do one and two, and then we're gonna do one since we already visited one, and this is gonna be on a. You want to do recursive
Well, with breadth first search,
or
isn't that you? We didn't learn how to do that recursively, right? We just learned
yeah,
how to do the while loop.
yeah. So you want to do while? So
Orcus,
while
yeah, we're thinking of doing that, but and that's what I was saying that with this problem it was like easier with just a pre-order, but we got these problems so that we could do breadth first search. We could practice that. So we're
yes,
just ignoring the depth first search solution to it.
yeah. So if you see you guys struggling, it's because we put
And
this
we're
on
doing.
us.
That's what I was saying. I said the idea because I thought it was cool. We could do two different routes, traverse at the same time. But now that I'm thinking about it, like we're just making it way harder. Let's just do what
Yeah.
you said.
You wanna
Just do breadth first
do?
search on both of them,
Uh-huh.
and then just compare the things.
All right. Fair enough. Fair enough. Okay.
So we'll create another
So
function, and then we'll
okay, let
do.
me
You know
delete
what
all
I'm saying?
this then. Yep. So we create a function. Let's call it breadth first search,
Yeah.
right? Which gets a root
Mm-hmm.
gets a root. Um. Okay.
Well, I just
So
realized, Orcus, are you in school? I don't know if you're in school or not, but I don't know. We see you all the time, but I never asked you like about you. Like, who are you? How are you doing? What you've been doing? What's your goal right now? I'm just curious. I see you all the time. We really enjoy you always viewing, so I think it'll be cool to learn a
to
little bit
know
more.
who's viewing.
Yeah,
Yes, sir. Hey, he's an OG too, bro. He's an OG.
yeah, that's an OG. All right. Okay, keep
Alrighty.
going.
So we're gonna return a list right here, right? Where we're gonna have a queue.
Hello, hello.
Oh,
You
Orc is
going to
going to
work?
work. Damn.
You going to work? Like right now, or that's like I don't know what you mean by that.
Okay. So we're gonna go. Uh.
The visited and the queues are outside of the function.
Mm, uh. I would say to keep them in here because we're not gonna use the same
Oh,
queue and the
we're
same
not
visited
doing.
for each.
Oh, okay. I
You
see
get
what you're
me?
saying. Yeah,
Yeah, and then we're gonna return a list of all the nodes that we have.
yeah.
You get me?
Cool.
I mean, I don't know. Maybe there's a easier
No,
approach.
no,
So
no, my bad. That was a
we're, yeah,
misunderstanding.
we're gonna go nodes here. Yeah, good, my guy. It's gonna be a list, sir. Yes, sir. All right, so we got a queue visitor. So in queue, we're gonna dot append. We're gonna dot append root,
Mm-hmm.
right? And then we're gonna do
Well.
while queue, right?
Mm-hmm.
While queue.
Well, the
So we're
length of
gonna
queue, right?
well, cause queue is gonna run out. It's gonna run out of things. Cause we're gonna pop each of them. You get me?
Okay.
Yeah.
Orcus is
Cause here,
23.
Michael Jordan, bro.
Michael Jordan
Michael
year.
Jordan. Alrighty. So, mm, so while queue, right? We're gonna so if we're in queue and we wanna append, we're actually gonna do visited here. All right. If you're getting confused by that, tell me because I'm also I'm wandering around
Well,
this stuff too.
I memorized the the code that we used in the last stream.
Really?
Mm-hmm.
Go for it, my guy. Take over if you want, my guy.
Okay.
Because right here I'm just wondering stuff.
So, I mean, I'm not saying what you're gonna do is wrong, but I
No, yeah, for sure.
memorized how. Let me see if I remember everything exactly. But so I didn't
Orcas
have. It was
from
like
July
this.
1st.
Huh?
Oh, from Orcas July 1st, I'm gonna go to work because I finished college last month. Hey, congratulations,
There
my
you
guy.
go. There you go.
Congratulations. Too easy, my boy. Too easy. Too easy.
Nice. Good stuff. So then it's like if root. Can I do this? Can I type this out? Do you think that's better?
Well, yep. Yeah.
Okay, type this out real quick.
The Orcas with the internship. Woo. Well, Orcas
So
he's living the life.
bang if root equals none, something like this, return.
Where are you typing it? Oh,
Oh,
here?
do you see?
Yes, but let me switch the color to
No,
something.
I'm typing it on the
Oh, on the LeetCode.
yeah.
Oh, okay. My bad. My bad. My bad. My bad. My
Okay.
bad. Okay.
So you wanted to do a function, which I
Uh-huh.
would agree to that. So def bfs root, and
Mm-hmm.
then you wanted to return a
Yeah.
list. You said.
A list. Yeah.
Okay. So then
Tap
we
that. Tap that.
do
Yes,
like
sir. Yes,
this.
sir.
Return
Mm-hmm.
list like that. Now that you know that root is
Ah.
not empty, then you append q
Ooh.
dot append
Okay. Okay.
root to the queue.
Mm-hmm.
From there, you do while, and like I said, I remember it. I remember it. So
Yeah.
lane
No worries. No worries.
q, and then I think it was greater than 0. So while this is greater than 0, then that's when node is going to equal the q dot pop at 0.
Mm-hmm. At
From
0,
there,
which
you're
is
going to check to
uh-huh.
see if the length of visited is less than equal to 1. If it is, then visited dot append node, no, dot append empty. Okay.
Okay. Okay. Oh. Okay. I see. I see. I
Yeah.
see. I see. Okay.
And then
You're
from
doing
there,
the
what's up?
okay. Okay. You're doing the okay. I see. I was thinking to instead of like you know how on the, I know which one you're talking about.
That's the one that what was their name?
Yeah. On Q.append, I think you have to append level. If I'm not mistaken.
It was this one right
On
here. It
18.
was Q level dot append no dot val. It was after that.
Wait.
And then you call
But on line 18, don't you have to put a tuple too, like root then
oh
level
yes, yes,
0?
yes, yes, yes.
Yeah.
So then you have level equals 0,
Uh huh.
and then you do root level,
Uh
and
huh.
then you have level right here,
Uh
less
huh.
than level. There it is. Less
Okay.
than
Okay.
level.
Okay.
And then trying to remember after that one, after you
Okay. You
append.
check. You you appended to if you first check if left child right child. I think if left and right child exist. If they do, you append it to
Yeah.
the to
If
do that, and then you do plus level plus 1.
exactly. Yeah, yeah,
Yeah.
perfect, perfect. Trying to remember, it was short. I did a shorthand. If root dot left.
Mm-hmm.
Um,
To Q level dot append
uh,
tuple.
wait, if, wait, how did I say it? If, oh, node. Then we're in node.
Mm-hmm.
So if node dot left, then I'm just, I
Uh,
know it's exactly what you said. You're gonna have
yep,
to
yep.
tuple this, so it's gonna be
Yeah, I
um,
think, but here I think instead of node, it's root because we're
root.
working with the root. Yeah, but if you to make it easier, just switch on the PFS on top on the function description, function declaration. Just switch it to node.
This.
Yeah.
Well, node.
Or
Well, node is this right here,
oh,
which
okay.
is
Never mind.
gonna.
Never mind. Okay. Yeah. My bad. My bad.
Let me see.
Yeah.
Let me think.
Yeah,
Let me
but you
think.
said if left side is found, you append it
Yeah.
to to the level, right? To
If
the level, like you
node.
said. Is it to the level?
You.
Yeah, I think you append it to the level. If node
You
dot
append
left.
it to the queue. You append the node to the queue,
Mm-hmm.
and then you add the level plus 1.
Yeah. Yep.
So if node dot left, then you do q dot append, and then you're gonna add the node, and then you're gonna do level plus 1, something like that,
Okay.
right?
Yeah. Yep. Yeah.
And then if node dot right, and then q dot append. Oh wait, is it node dot left? Right.
Yeah. Mm-hmm. Mm-hmm. Mm-hmm.
Right. Plus one. Something like that.
So, you want me to double check?
No, we could test it. We could test it. So then once we're done with this, then we return list, right?
Uh-huh.
Return not list. You return visited.
Yep. I
Now you
like it. I
say
like it.
if BFS P equals BFS Q
Mm. Wait.
return,
Visit it?
right?
Is it visit it?
That's
Oh,
the
yes.
final.
Yes. Yep. You're good.
Okay. And
Mhm.
then return true. I don't know if that's gonna work, by the way. I'm just
Yep. No,
else return false. Something like
false.
that.
Yep. Run it.
I'm scared.
Hey, we're running it. We're submitting it.
Okay. Where are we at?
928.
Q level dot append node.
Q level.
That means I missed something because I ran through. I
Mhm.
encountered this as well.
Oh, it's because
Doing
you're
some.
doing Q. I think it's visited. Because you're appending
Yeah.
into the queue.
Yeah, I think you're
Yeah,
right.
there we go. Mm-hmm.
Okay. Now, let's see.
Ooh, you see? Okay, right here, I see the problem here. Okay, since um what was I gonna say? Since two are in the same level, right? It's gonna put them like on the same array. You get me? So that's why it's not gonna differentiate which one is which, if that makes sense.
No, I think the problem is we're not putting in null into the array, right?
Yeah, I was gonna say we have to put null into there. So if you say if root equals null or if root equals none,
Which is this. If no dot
yeah,
left, else, then you're gonna put. Um, I want to
you're
learn
gonna
how to.
append
What's the
it.
shorthand? You're gonna pen null,
Yeah,
right?
yeah.
Uh, in the queue
In is it in the visitor?
because if it's null, then that means it goes
Mm-hmm. I think it's in
back
the
up here.
visitor, no?
I would think so too.
Yeah, and you just put Q that append um um, 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 um. So you do the
Visited
visited. Uh-huh.
level dot append um none.
Uh-huh.
Some, something like that.
Yeah, it's outlive. Oh no, it's else. Never mind. Damn, today's not my day, bro.
Right? Don't you think that right? This is the right spot?
I feel like that's the right spot, but I'm think no, yeah, that's the right spot. Yeah, for sure. Try running it. Okay. Print out the visited. Let's see what's. Just do print BFS P.
Oh.
Yeah.
You just all you have to do is just do that?
Yeah. Uh-huh.
Oh, I almost clicked that.
It's starting, bro. Okay, that's good. Go to the number 2. That's good too.
No, this one should say.
That should say false. Mm. You see, I was thinking instead of doing levels, let's just put them all in order as we like instead of putting like a array instead of array, right? Why not just like put them all in order, right? Without knowing what level it is. You get
Okay.
me?
Yeah.
Yeah. So there'll be some like and then we do length of queue. We remove level. Then I think we remove the that if statement and the visit it. Yeah. Yeah. Uh-huh. Then we and we remove the tuples. Yeah. The parentheses. There you go. Uh-huh. There we go. And that should give you something similar to that.
If no dot left. So let's say this one right here.
Mm-hmm.
If it goes to left. Well, if it's none, then it
It's
goes
gonna
to else. So
it's gonna
visit
append
dot
none.
append none.
Uh-huh. If not, it goes to q dot append right.
No dot right.
Mm-hmm.
It
Then it
does.
goes on the loop.
Then it does a loop.
Oops.
The length of the queue is updated, right? So now, like,
It's 1. So
you
we
want
appended the q.
and
We
okay,
appended the right. Then the
pops
2 is
to
gonna go. It's gonna add
okay.
2.
You want to run it?
Uh-huh. Yeah, run it, run it. Mm-hmm. Hmm. Let's see, let's see. 1. Yeah, it's gonna we had something similar to this before. We had like a similar problem to this where 1, which one is P? P is left side, right? Left.
Yeah.
Mm-hmm. Mm, so we do 1, get appended, and then we go to left shout, get appended, then we get right shout. Mm, I think that's it because on 1, right? We go to left, we append the Q, right? Right? Since 2 exists, right? So we're in the first on the first if statement, no dot left, right? Since 1 has a 2, it gets appended, right? On line 31, right there. Line 31, it gets appended, right? And then we go to the other if. The other if checks the right. Since it's no, it gets added to the visited. You get me? So we have to skip that part in there. Uh, so
Wait.
you get me?
No. Well, I'm confused because this right here,
Uh huh.
it's saying the node it's at is one. The node
Uh
to the
huh.
left is none.
You see, that's a problem
Why?
because
And I'm trying to figure out why. Did you just explain
that
why?
yes. Explain.
Okay.
Go down, go down, go down, go down a little bit. So there we go. Okay, so 1, right?
Where are
We
we
go to
at?
1.
What line?
Let's start the while loop.
Okay.
21.
Okay.
1, right?
The length
It's
is
already
1.
queued in. Yeah, 1, right? We pop it, right?
Okay, so it's
So
1.
visit it dot append. So now visit it has 1, right?
Yes.
Then we check left. Does left have something? Yes.
Yes.
So it gets appended to the queue, right?
Okay.
But guess what? We still have this other if over here on the bottom, right? Note that right, it doesn't have nothing, right? So we don't append it to a queue. Therefore, we go to the else and
Oh.
we append the 0.
Yeah.
You get me?
Yeah.
So that's where we have the trouble. So I was thinking we can use the keyword continue, right? As soon as we mm, let's say we hit visited.append. Wait, no. Um I'm thinking.
I just honestly, I think we don't need these. I think
Uh
it'll look,
Go
look.
for it, go for it.
Let's see, let's
Yeah,
see.
yeah. Let's see. Okay. Uh Give
Okay,
me
we
1 and
do.
2. We do
Okay,
need them because we need to fill in the zeros.
if
Because we are just adding all the elements. We're not specifying what level they are or what order are they in, right?
let me see this again.
So that's why if we hit a 2, right? As soon as we hit like a node, we continue to the next iteration because we don't want to go to the right side, right? And then, well, we do want to go check if it's a right side. Ooh, hmm. This is an interesting dilemma. Very interesting. Calm down, my boy. Calm down, my
I'm
boy. Calm
sorry.
down, my boy. Calm
You know
down.
what bothers me?
Uh-huh.
You know what bothers me
Hmm.
is that we could solve this problem with
Oh
just
yeah,
for
we can.
search.
Can we?
Well, yes,
Oh yeah, yeah,
that
yeah, yeah.
for like
With pre-order traversal.
pre-order, post-order, in order, don't matter. At least I think it doesn't matter. You're there. So, anyways,
Yeah.
it's just annoying me that I decided that we should do breadth first search on
I
this
mean,
dumb problem.
it's 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 we just have to figure out
Hold me back.
when to add that 0. That's where we have to figure it out. That's the only thing. Alrighty. Apart from that, we're good. We're good, bro. Calm down, bro. I got this. We got
Hold
this,
me
bro. I'm gonna
back,
hold you back.
man.
I'm gonna hold you back, my guy. I'm gonna hold you
So
back.
we go 1, 2, and then it checks the right. We need to check the
So
right.
we
That's
have to check the
it's
right.
breadth
Yeah.
first search.
Uh-huh. Uh-huh.
So it's 1, and then the next one's gonna be 2 and null, and then the next
So
one.
2,
We
right,
need
we
the
gotta level
arrays.
pen.
We need the level order.
Either way, if we have the level order, we're still gonna have the same thing. Because in the level order, we still have to add that 0. Or you still have to add that null component. Because it's just gonna give us the number or the values that are in that level. For example, on 3, it's gonna give us 2, 1, 1, 2, right? It's not gonna give us or 2, no, low, then no 2. You get me? We still have to figure out that idea. And I feel this way is easier because we don't have to worry about the levels. We just have to worry about the structure of the array. You get me?
So, could you explain how it needs to look again in the output? It needs to say
To
1, 2,
1,
null.
2, no,
The other one
yes,
needs to
and the other
say
one says
1, null,
1,
2.
no, 2. Exactly, exactly. So here, I feel like we just
1, 2, null.
mm-hmm. I'm thinking. I'm also thinking, my guy. I'm thinking right now. You're not alone. You're not alone. Uh, I don't think that's gonna work, my guy.
Do we need this? We didn't update
Yes, we have to
this.
check. We have to check.
But that's gonna put it into an array. We
Yeah.
don't need that, right? We need the
I
base
don't
case,
think.
but I'm just saying we don't need it to
No, the
return an
array. Yeah,
array.
yeah, yeah. Think about it. So let's work it out. Let's work it out. Go to one, right? Then we go to left. If left is if left is okay, so we can add to the queue, right? Those zeros or that none, right? Q dot append none. Say if uh if node equals none, right? We
Mm-hmm.
add 0 to the visited, right? And then we continue to the next iteration. So let's say on number right here on 24, on 24, right there. Yeah, you're gonna do an if statement right there. And say if node, right? If equals none, yeah. Okay. You're gonna do visited dot append none, and then we're gonna continue. There you go. I feel that would work. You get me? No, maybe, maybe so. Bro,
um,
what you laughing, my boy? What you laughing, bro?
it's in the queue.
Uh huh.
It's gonna check. It's gonna pop the null.
Mm-hmm.
If node is if node is none,
Uh huh. So if none is none, we're gonna on the visited, right, which is where we're gonna return. We're gonna add a none, right? So now we are
and then continue,
append
meaning don't do any
the
of this.
and go to the next iteration, which is gonna pop, right? We're just gonna start from the line 21 from the top, right? I don't know if that's gonna work though.
Continue.
Yeah, continue means like stop there and continue to the next iteration. Like don't do anything else. But I don't know if that's gonna work though. Mm, yep. I don't know if it's gonna work. I'm doubting myself now.
Oh,
Oh, oh, oh, oh, oh,
one, two,
oh,
none.
oh, alrighty. Autopilot.
One, none, two,
Oh,
none, none.
should work now.
Something like that.
Yep. Ooh, 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 baby. Sir, sir.
All right.
Yes, sir. Let's see. Give me one
With
second, my
just
guy.
with just one in there, it does the correct output, and then with
Uh-huh.
nothing in there. Oh wait.
Toss.
Uh. Oh.
Ooh, we have to
Mm,
check the values.
what do you mean?
Ooh, All right, never mind, never mind, never mind. We good, we good, we good.
All right.
Come on, my
You
boy.
think so?
Come on, my
You
boy.
think we can
Come on, my
submit
boy.
it?
Come on, come on, come on, come on, come on. Ah! Wow. Let's
Good
go.
stuff.
Let's go. Let's go. Let's go. Hey, now we learned something new, bro. Now we learned something new.
I'm
That
upset
every time we figure we need that zero, just add it in there, and if it is, just boom. Bro, why are you upset, my guy? Why are you upset, my guy?
because I'm just mad.
No, don't be mad, bro. Be happy. Life is beautiful. Life is beautiful. Hey, thank you, Orcus. Thank you, Orcus. Thank you, thank you, thank you. Ooh, ooh. Isn't there if something even better? They're called tertiary Python. Let me see. Ternary Python.
Does
Yeah.
this work?
No. It has to be before. It has to be q dot append node left if node left else. So you're gonna move the if node dot left in front of, there we go, and remove the colon. Yeah. And the else colon, no, yeah, remove the else colon. Yeah, something like that.
So like this.
Yep. Mm-hmm. Uh-huh. Yes, sir.
Life is beautiful.
But that reminds me, I don't know if you remember compound sentences with the if and stuff, where if you have a, no, is it complex sentences? Where if you have the if in the middle, you have to put the comma, like you don't put the comma, but if you have it in the front, you move a comma. So it's something weird like that. That reminds me of that. Good old days, good old days.
I just scared myself. Did you see what I
Hey,
put?
bro. Nah.
I changed it, like trying to like make it look more clean or clean, and then just three test cases were wrong. And I got scared for a second.
Nah, bro. Hey, first
All right,
one done, bro. Let's go. Let's
all
go.
right, good stuff.
Too easy.
You want ready for the next one?
Hey, bro, we have to explain it, bro.
Okay,
You're rushing, you're rushing.
all right. Am I explaining?
Yes, sir.
All right. Let me take out my gum. All right. So for this problem, we have same tree, and you want to check the nodes of the tree. We're going to do BFS, so by breadth first search. We're going to do level order, so that means we're going to start from the top one, check that level, which is 0, and then you check the second level, which is 2 and 3. And if there was more, you would check that number all the way across, like horizontally. So
Yes, sir.
if you, for example, 1, if you do horizontal checking, 1 and 1 is the same. 2 and 3 and 2 and 3 is the same. So that means this is true. If you go on the next one, you have 1 and 1, that's the same. Go on the next one, 2 and nothing, which is none. That's how this tree is. And then the other one is none and 2, which is not the same. So that means that's false. Since you're doing level order, you're checking horizontally. So lastly, we have another one. You're doing 1 and 1. Those both are the same. The next one, you're doing 2 and 1. And is that the same as 1 and 2? No, it's not. So you return false. How that's done in the code is you do BFS, which is using queues and a visited array. And the base case for that is if root is none, then you return, you just return. And then you want to append the initial root to the queue. So once you have the initial root in the queue, you're going to check the length of the queue is greater than 0, and then you're going to just pop that node from the queue. So now technically the queue is empty. Before it had the root, now it's empty. With it empty and the value of the node equal to the value of the root equal to node, then that means we're going to be checking node, and we're going to see if node is null. Then this one gets complicated. Hold up. I'm going to skip this part because this one's not applicable right now. So anyways, you keep, since the queue, you just pop the value, and now you have the value of, let's say for this example, you have 1. You have the value of 1. So in our visited, which is our final array, you're going to pin the value of 1 to visited. So now technically we have 1 in here. And now the queue is empty so far until we add more. So that's what this line does, is it adds more to the queue if there's more nodes to traverse to. So you check node.left of the current node that we got from here. And from this example, there is another node. It's 2. So then you add 2 to the queue. So now the queue has 2. And then you're going to check if there's a node on the right side. So is there a node on the right side of 1? Yes, there is. It's 3. So then you add the node 3 to there. And then you loop again. So the length of the queue is now 2, 1, 2. And then you're going to pop the first thing, which is 2. So you get 2 out of there. Now node equals 2, or the node 2. And then if the node is none, which is not, you're going to keep going. You append the visited node to there. So you do 2, and then you keep going, keep going, keep going. Where this is applicable is, let's say you're on example 2 and you do node.left. So for this tree right here, if you look on the left side, there's nothing there. So if node.left, if it's none, meaning there's nothing there, then you append none to the queue. So now let's just say none is in there. So the next time you iterate, you're going to pop none out of there. So none's gone. And now you're saying if node is none, which it is because it just popped none from the queue, then you're going to append none to the visited. So now the visited would be none. And then you continue. So you ignore all this stuff right here. You ignore and you go to the next iteration to see if the condition still applies. So that's why you have this like base case in a way, right? It's considered a base case, I guess.
Yeah,
Kind
you
of,
can say so.
kind
Yeah.
of, not really,
Mhm.
but I guess.
This is more like a catch case, like you
Yeah.
catch something. That's maybe I don't know if that's a term or something, but I consider it like more of like a catch.
I guess
You know
base
what I mean?
case would be more so with recursion, right?
Yeah, yeah.
Yeah. So anyways, that's kind of the basic of it. And then lastly, you return the visit array, which has the total level order traversal nodes. So if we just fast forward and we're back on example 1, the visit array would look 1, 2, comma 3. It would look like this. So you return that, and then what this does is it calls both functions for the tree P and the tree Q. So this one would return the array 1, 2, 3. And then if you do Q, which is this one right here, it will do the same thing. It'll do 1, 2, 3. Since those two equal each other, it returns true. And if they don't, it returns false. So that's what that is.